Welcome children, I welcome you all to the digital lessons. By the end of this lesson, you will be knowing certain terms like motion, rest. You will able to define uniform motion and non-uniform motion. You will also learn about types of motions. Children, what is motion? Have you ever observed about the motion? Motion is a common experience. In our day-to-day life, we experience motion in a various ways. Motion is a common experience in our life. For example, birds flying in the air, buses, autos, cars, bullock carts, moving on roads, and even train also move. So, with this, you all may be thinking about motion is nothing but changing from place to place. In this session, we will be learning motion and time. So, today our topic is motion and time. We will learn in details about motion. You can see here the butterfly is moving all around. So, it exhibits motion. Here you can see a dog. What is the dog doing? It is relaxing. So, here we can say the dog is at rest. Now, look at the next video where you can see, children, here you can see the plants and trees are moving. This is a common experience which we face when we travel, that is, if we are going in a train or a bus, and when we look out of the window, what we see? We see trees, buildings, electric poles, etc. are moving. Children, just imagine, are they really moving? Then who is in motion and who is at rest? So, here we will be studying exactly who is in motion and who is at rest. In a car, a driver is sitting. He is in motion with respect to the surroundings. Now, he is at rest with respect to the car. That is, after travelling for a particular period of time, we see the driver and the car are within the same surrounding. So, with this we can say the driver is in rest when compared to car, whereas he is in motion when compared to the surroundings. So, an object can be both in motion as well as at rest when compared to the situation. Just have a look at the picture here. In this picture, you see an engine is moving over the tracks, and you can also notice a check post there. Now, children, just think over where the train is. Did the train cross the check post? No, the train did not cross the check post. It takes some time to cross the check post. Here you can just see where is the train now. The train has crossed the check post and it has moved away. So, who is in motion? Now, the person who is driving the engine, what do he feel? He feels the check post is moving. But is there really the check post moving, children? No, the check post is not moving, but the train is in motion. Here you can compare both of them in this picture. In the first picture, you see the train hasn't crossed the check post yet, but in the second picture it has crossed. So, with this we can say the check post is at rest, whereas the electric train is in motion. Children, now we also see another picture here. You see a girl is riding a bicycle. Now, she started at a particular point and she has come to end of the road. Now, what do we get clarity about this? We can say the girl is in motion with respect to the surroundings, whereas she is in rest with respect to the bicycle, because the distance between the cycle and the girl did not change even if it is at the end of the journey. From the discussion, a body may be at rest with respect to one set of surroundings at the same time in a motion with respect to another set of surroundings. So, motion is relative to observer. That is, if a person is moving, he can feel the objects around him are moving, but it is not true. They are at rest, only the person who is travelling is at motion. So, we understood from this that a set of surroundings changes according to the observer. So, try to answer some questions here. How do we decide which object is at rest? Are these trees, building, electric poles, etc. are really in motion or rest? So, try to find out an answer by yourself. Shall we define what is motion? An object is said to be in motion if it changes its position with respect to its surroundings in a given time. So, we call them as they are in motion. Then, shall we define what is rest? An object is said to be at rest if there is no change in the position with respect to surroundings in a given time. So, I hope you have understood the term motion and rest. Now, if we come to the motion can be of two types, uniform motion and non-uniform motion. What is uniform motion? If a body covers equal distance in equal intervals of time, it is said to be in uniform motion. Children, you all having clocks at your house. What is the time in the first clock, children? It is 9 o'clock. Now, to become 9:05, how much time it takes? It takes 5 minutes. That is, from 9 to 9:05, it takes 5 minutes. Here you see the time is 9:10. How much time it took from 9:05 to 9:10? It took another 5 minutes. Now, you can see in the fourth picture, that is from 9:10 to 9:15, it took another 5 minutes. So, in this what we can say is the minutes hand is taking 5 minutes to cover 5 minutes distance. So, it is changing, it is taking 5 minutes time to cover the distance from number 2 to number 3. So, with this we can say the time is in uniform motion. So, the time takes a uniform motion. What do you see here? A fan is rotating on its own. Now, for completing one rotation, it takes 1 second, and in the second it will complete another rotation. So, like that, if we see, we can understand an object covering equal distance in equal interval of time, we call it as uniform motion. Now, look at another example, children, that is the train. So, here the train is taking 2 seconds to complete one revolution. So, for the second revolution, it takes another 2 seconds. We can say that this engine is in uniform motion. Unless it stops at the train, it will be in the uniform motion. So, now shall we discuss about the non-uniform motion. If a body covers unequal distances in equal interval of time, it is said to be in non-uniform motion. You might be seeing the birds flying in the sky. The birds do not have any specific time. They make a move of their own interest. That is, they may not, there is no time bounded for the flight. So, it is a beautiful example, they are in non-uniform motion. So, shall we have a comparison between uniform motion and non-uniform motion? Children, we will take another example of uniform motion. Here we see a train, a toy train is taking 2 seconds to complete one round. For making the second round, it is taking another 2 seconds. Like that, it is in continuous motion. So, we can say this is in uniform motion because it is taking equal time for each round. Now, we go with the non-uniform motion. What is non-uniform motion? If a body covers unequal distance in equal intervals of time, it is said to be in non-uniform motion. To learn about this, we have to look at the following example. The birds flying in the sky. Do you think they take any particular time? They start at the particular time and do they end at a particular time? No. Whenever they feel to fly, they fly, and whenever want to take rest, they take rest. They do not follow any particular uniform motion. To study in details about the uniform motion and non-uniform motion, we will take two cars, that is car A and car B, and we will compare them. Children, to understand in details about uniform motion and non-uniform motion, we compare them by using car A and car B. Here car A covers 150 meters in the first 10 seconds. In the next 10 seconds, it covers another 150 meters. So, total it has covered 300 meters. Next, in the next 10 seconds, it is covering another 150 meters, thereby total 450 meters. And even in the last 10 seconds, it is covering another 150 meters, thereby total 600 meters distance covered by car A. Car A is covering equal distance in equal interval of time. So, it is a beautiful example of uniform motion. Now, look at car B. How much is the car B travelling in the first 10 seconds? In the first 10 seconds, it is covering 50 meters, whereas in the next 10 seconds, it is covering only 40 meters, thereby total 90 meters. Look at the third 10 seconds, that is from 20 seconds to 30 seconds time, it is covering another 90 meters, which is more than the first and the second time. So, and you look at distance between 30 seconds to 40 seconds, how much distance it is covering? It is covering 50 meters. So, you can see here 50 meters, here 40 meters, here 90 meters and here again 50 meters. So, car B is in non-uniform motion as the car B is travelling unequal distance in equal intervals of time. Here we will tabulate the information of car A and car B. Car A is in uniform motion as it is covering equal distance and equal intervals of time, whereas car B is in non-uniform motion. So, with this we understand there are two different types of motions, uniform motions and non-uniform motion. Children, in your daily life experiences, just try to make out the uniform motions and non-uniform motions. Based upon the path taken by the bodies in motion, we can classify motion of bodies as translatory motion, rotatory motion and oscillatory motion. We will learn in details about all the three motions. Translatory motion. If all parts of the moving body move in the direction of motion, then the motion is said to be translatory motion. This translatory motion is again rectilinear motion and curvilinear motion. So, we will learn about translatory motion by taking the following examples. Look at the video here. Here the car is moving in a straight line. So, all the parts of the car are in straight line. So, we can say the car is in translatory motion, or it is also called as linear motion. Let us look at another example here. Here you see car moving in a straight line. You can observe very clearly the road is straight and the car is passing along the road. So, it is an example of translatory motion. So, this is a daily life experience and it is a beautiful example of translatory motion. Children, so this translatory motion is again two types. One is the rectilinear motion and other one is curvilinear motion. We will define and learn what is rectilinear motion. If a body in translatory motion move along a straight line, then the motion is called as rectilinear motion. That is, when you are traveling straight on a path is an example of rectilinear motion. Then what about the curvilinear motion? If a body in translatory motion moves along the curved path, then the motion is called as curvilinear motion. Children, we will take the examples of rectilinear motion and the curvilinear motion. You all will be playing carrom board and you will be hitting a striker. How does the coin and the striker move on the carrom board? They will be moving in the straight line. So, the motion of the coin are the examples of rectilinear motion. If we talk about the curvilinear motion, here in the speedometer, that is the bikes have a meter called as speedometer. You look at those speedometer needle. How does they move? They always move in a curved line. So, we can take that as a curvilinear motion. Children, here I have a question for all of you. Can an object be in both rectilinear as well as curvilinear motion? Yes, an object can be both in a linear as well as curvilinear motion. For example, a car taking a turn at the road ends. They will be moving in a straight line. Simultaneously, they will be moving along the curved path. So, that can be a beautiful example of both rectilinear and curvilinear motion. Now, we study about the second type of motion, that is the rotatory motion. What is rotatory motion? Motion of all particles of a moving body following a circular path with respect to a fixed center or axis of rotation. For this, we take few examples here. First example is, look at this wheel. This wheel is rotating around a particular point. If you look at very closely, here you can just see this is the fixed point. Around the fixed point, you can see the entire wheel is rotating. Shall we look at another example of rotatory motion, children? Here you see this is an axis which is fixed at the center. Around this axis, this seat is rotating. We also observe certain other examples of rotatory motion in our daily life. Earth rotating on its own axis. Another example is, you will be playing top. Whenever you leave a top, what happens? It rotates on its own axis. So, that is also another example of rotatory motion. The cycle wheel also can be taken as a rotatory motion. Next, we study about the oscillatory motion. What is an oscillatory motion? When do you call a motion as an oscillatory? The to and fro motion of an object about a fixed point always following the same path is called oscillatory motion. You might have seen a pendulum clock. For this, simple pendulum is an example. From the mean position, it will be moving to and come back to the mean position and again moves in a fro motion and again come back to the mean position. That is, this motion of to and fro is an example for oscillatory motion. Children, To get clarity about the oscillatory motion, just have a look at this swing. This swing is in oscillatory motion. It is moving to and fro, that is from the mean position it is going once left and once right. So, this is a beautiful example of oscillatory motion. Another example also you can see here. Look at this swing, children. It is also moving to and fro, that is it is making oscillatory motion. So, let us learn more about the motion. The motion can be also divided into slow and fast motion. We observe many objects in motion in our daily life. In some cases, objects move slowly and in other cases, they move fast. For example, a man is running and another man is walking. Who is slow and who is fast? Here, the man who is running is fast, whereas the person who is walking is slow. I hope, children, I am clear with the motion and rest. So, shall we recall what have we learned once? When an object changes its position, then it is in motion. When there is no change in position of an object, then it is in rest. Next, we also studied translatory motion, rotatory motion and oscillatory motion. We also studied uniform motion, which is covering equal distance in equal time. Then what is non-uniform motion, children? Unequal distance in equal time is non-uniform motion. Children, am I clear with this lesson motion? We will learn about time in the next session. Before that, I would like to give some questions. Improve your learning. Parts of a bicycle, it is in motion. Here you see the wheel. The wheel is in which motion? Just think out and an answer to that. What about the cycle chain? The pedal with the arms. The movement of the rider. Just think over which is in motion, which is in rest and which part of the cycle is in which motion. You can observe in your daily life and you can answer these questions. When can you say an object is in rotatory motion? We learned about rotatory motion, right? So, just write down when can we say an object is in rotatory motion. Give some more examples of translatory motion. You all learnt about translatory motion, right? Just take down it as an homework and try to write them. I hope I am clear with the concept motion. Still, you want to learn anything for the better understanding of the concept, please visit our website SCERT. Children, I think we have completed the lesson motion. To learn about time, we will